In this video, we're going to show how to solve systems with matrices. Our goals are to understand the setup and to solve applied problems. So let's consider this guy, x plus 2y equals 6 and 3x plus 4y equals 7. Of course, we could solve one of these equations for one of the variables and use substitution to help us find the other. However, we're going to go ahead and do this with matrices instead. So with matrix equality, we know that we can always write an expression as a matrix, and we can equate two matrices assuming that their components are equal. So for example, here by writing this 2 by 1 and this 2 by 1, I'm claiming that x plus 2y is the same as 6, 3x plus 4y is the same as 7. Now what I'm going to do is, because this is a matrix, and because I kind of see that, well, if there's a 1 here, that I have 1, 2 times x plus y, I have 3, 4, x and y. So what I'm going to do is I'm actually going to go ahead and lift out the xy matrix, thinking about it as a column matrix, and I'm going to write it like this. Okay, so all I've done here is I've said, alright, well I see that this is the sum of products, so I'm going to lift up the xy, and you can see if I multiplied it back in, I'd still get 1x plus 2y, 3x plus 4y equals the bracket 6, 7. Okay, well you might just say now, okay, let's make a parallel here. If I wrote 3x equals 10, or 3x equals 9, how would you solve that? Well, a lot of you probably divide by 3 to get x equals 3. However, if I go over to my calculator and I try to divide, so I have these matrices already plugged in, if I try to take this matrix with the 6, 7 and divide it by the matrix with the 1, 2, 3, 4, let me just show you that these are the same. So there's my 1, 2, 3, 4. Here's my 6, 7. If I just go ahead and do the B matrix and I divide it by the A matrix, I run into a data type error. Now unfortunately there's no such thing as division in matrix land. So the one way you can think about this as, well, if instead of dividing by 3, what if I just multiplied both sides by 1/3? Would that give me the same thing? Well, absolutely it would. Now 1 over 3, another way to write that is 3 inverse, or 3 to the negative first power. And that, if you plug that into your calculator, will still give you 3, because you're really taking 9 times 1/3. Okay, well in matrix terms, the question is, well, how do I multiply by the inverse of this? What is the inverse of this? Without going through too many of the details, because we won't do that, if you're interested, go through and look at the section. But if I just come over here and I type in matrix A, and I get the little inverse button by pressing X inverse, it's going to produce an entirely different matrix. It says that the inverse of A is -2, 1, 1.5, -0.5, which you'll notice is not as simple as just doing 1 over 1, 1 over 2, 1 over 3, 1 over 4. That's not what you get. But notice now if I take both sides and I multiply by this, skip ahead here a couple of places, and I say A 1, 2, 3, 4 xy equals 6, 7. If I go ahead and do this, and I just call this A times x equals b. So I'm using capital letters, and now I'm going to solve this. I'm going to say if I multiply both sides by the inverse, now for important reasons that we won't discuss here, it's important to multiply the A inverse in front if you do it on both sides. So what do those come out to? Well, ideally those should come out to 1. Now if I take A, just to prove this, and I multiply it by A inverse, I get something that has just 1s and 0s. Now as it turns out, so this basically becomes what I'm going to put in parentheses as 1x equals A inverse B. This 1, the reason we can call this a 1 is because if you take any matrix and you multiply, any 2 by 2, and you multiply it by 1s across the diagonal going this way and 0s everywhere else, like 2, 3, 4, 5, guess what you're going to get? You're going to get 2, 3, 4, 5. So you get the same thing back. So this one matrix, we're going to call that the identity matrix, because anytime you multiply by the identity matrix, it does not change the result. So we get x equals A inverse B. Alright, well A inverse is that thing that we found in our calculator, which again we won't go into detail as to